So tuples is also a data structure similar to what we had, the list and the dictionaries. So what is a tuple? So it's just like a list. As you can see here, if you have some assignment statement like this, basically you are assigning uh, this, you are defining a tuple and assign it to a variable x. And what is inside the tuples is are three strings, three names, more specific, right? Glenn, Sally, and Joseph. So they have elements with their index starting from 0, right? So that's why you could access each of the elements just using the name of variable and two square bracket uh, plus this um, number index, right? So in this case, this index is 0, 1, 2, same thing as we had in the list and also the strings. And turns out with index 2, you will access this uh, string, which is Joseph, right? Um, Also, if we look at this example, basically this y is also a tuples. And again, when you define a tuple, you have to remember basically you are using this um, parenthesis. Uh, and all the different elements in the tuples will be put in this inside this parenthesis, and you separate each of the element using the comma, right? So basically, this y is another tuple, and if you just simply use print function, it will print all of the three tuples. So just remember different data structure has different way to define. For a list, we have the square bracket, right? All the element will put in between of the two squared bracket. And in dictionary, we have this curly braces, right? And for a tuple, we use this parenthesis. So this is a list. This is dictionary. Just to put the dic as a for short, right? And we have this tuples. Right? So when you look at the way how the code defines the data structure, you could have some assumption what it is, right? What type it is. So it turns out this is how you define tuples. Also, you could use a for loop and a iteration variables to loop through the tuples. Basically, you will access each of the tuple and print it one by one in this specific example because you're essentially printing each of the element inside the tuple. Right, that's how this tuple works. You might ask, what's the difference between a tuple and a list? So first of all, tuples are immutable, meaning you are not able to modify it. Basically, once you create it, there's no way to alter its content. Uh, at this point, it's quite similar to a string. For a string, you cannot modify it as well, right? So if we take example of the three different data structure, this one is a list, and this is a string, and this is a tuple. So as you can see, we defined a list, and then we could easily modify any elements inside this list by using its index and this assignment, value assignment statement. And you are able to do so, right? But for a string, for example, you have this string ABC, and it is assigned to be to this y variable. And if you want to modify uh, the element with index 2, it turns out you are not able to do it because string is not mutable, is immutable, right? That's how a string um, would would how what happened if you want to modify a string. Similar case happens for tuples. So you have this z, also it's a tuple, and you have three elements there, but you want to modify the elements with index 2, and again, you have this error information. That means you're not able to change the value of the tuples. So that's the first difference between a tuple and a list, right? Another thing is you will say for a tuple, there are a lot of functions which are not available. So basically, you think tuple is same as a list. For list, there is sort function, there is append function, and a reverse function, right? And you just want to do the same thing with tuples. And it turns out if you try to use these functions with tuples, what end up is you cannot do it. There will be error information because there's no such functions for tuples. So if you further look at what could be the methods or the functions associated with tuples, use this dir function. So for example, if you define a list, an empty list, and also an empty tuple, and use the dir function with the two different variables, and you could see for list, it has these all different functions or the methods associated with it. It means you could directly call these functions and make change to the list. But if you look at tuple, well, these are the two only functions or methods you could utilize. And all the rest are not available to tuples, right? So when you try to use, like, for example, append, insert, pop, remove, reverse sort, you will have error informations. So that's another very important difference between tuples and a list. All right. But again, you might ask, then what's the point to have tuples, right? Because it basically does similar thing to list. On the other hand, it has less capabilities because it does not support so many other functions, and you cannot change it. Then why we need tuples, right? Why we don't use lists? Why this tuple should be there? Actually, the answer is tuples are more efficient because as you already know, there are less functions, less method associated with tuples. Also, tuples are not mutable. Basically, the benefit is in you avoid the implementation of these functions, and also you avoid the mechanisms to realize the modification of the elements with tuples. And as the payback is, it's how you when you use tuple, it will be more efficient, and the memory consumption will be less if you use tuple to store the same content versus the one you use list to store them. And in that sense, if you are trying to using some, I mean, if you are trying to making temporary variables, I would say tuple would be a better choices over list. And if those content that you want to start in tuples are in a larger amount, this kind of benefit will be more significant. For smaller amounts, there's no difference. But for a larger, let's say you are storing a lot of strings extracted from I would say an article or something, and you don't want to make change of what you stored, probably tuple will be a better choice over the list. So that's the, I would say, the payback for not supporting many functions using tuples. Any questions so far? Nope. Okay, good. So just keep it in mind, right? And I will give you little practice in the lab sessions using tuple, and you will get familiar with how you're going to use it. So for the assignment of a tuple type variables, there are multiple ways. It's quite flexible, right? So previously, you see the case, you have one variable and you have a tuple and assigned to this variable, right? Or you could do something like this, right? So on the right-hand side, it is a tuple. There are two values. One is for, another is a string thread, right? And what you could do is you can even assign this tuple elements by elements to two variables, x and y. By doing so, you are actually assigning 4 to x and this string thread to y. Turns out if you print y, it will directly print its start value, which is thread in this case. So that's a very interesting way to use, and which is quite different from when the usage of a list, right? So similarly, in this case, two tuples 99, 98. I mean, two elements in the tuple 99, 98. And if you assign it in this way, again, you are assigning value element per element, meaning 99 is assigned to A and 98 is assigned to B. And if you look at A, it is 99. So that is a very interesting a feature associated with tuples. Also, tuples could be used together with the dictionaries, right? So in dictionary, the item method will return a list of key and values, and it could be stored as tuples. So if we look at this example. We have a dictionary D defined, which is an empty dictionary. And then we have these two assignment statements. So you create a new key, CSEV, and associate a value 2 with this key, and another key C1 and another value 4 to this key. So using the items method or items function, you could loop through the dictionary, and it turns out you are creating each a series of tuples, and each of the tuple will consist of a key and a value. So basically, one tuple is the CSEV and 4. Another tuple is C1 and CSEV and 2 and C1 and 4. So it turns out you will have these pairs, and each of a pair will be a list of tuples. So it turns out that if you execute this print function, you will have these result. And that's how the dictionaries are linked to tuples. So here shows another way to use the tuples. So again, use the items, and it turns out this tops is the is a list, and this list consists of two tuples. One is the CSEV together with 2. Another one is C1 together with 4. So that's how this items function work with tuples. All right. Any questions? Okay, good. And again, we will have some examples when we have the lab sessions with tuples. All right. Another thing is the comparison using tuples. So the comparison operator will work with tuples and other sequences. So what it does is they will compare two tuples starting from their first elements. And if the two elements are the same, they will go to the next element and compare it until it finds the elements they are different. Then the comparison will be terminated. Let's look at examples. It's a little confusing, but let's look at an example you will understand. So if you want to compare this tuple and this one, basically you are first looking at the first element of the two tuples. Is 0 less than 5? And they are not the same, right? And indeed, 0 is smaller than 5. Then basically it satisfies the this condition, and it will directly return true because A, 0 is not same as 5. B, 0 is indeed smaller than 5. So the comparison result will be true because 0 is smaller than 5, right? So that's the first case. So what if their first elements are the same like the one showing here? So basically, when they compare their first elements in the two tuples, basically they are the same, and then they will look at, okay, how about this? And this is 1, and this is 3. They are not the same. Okay, we could compare it. And 1 is smaller than 3, yes. So directly return true. And you don't need to care about this element because for the second one, for the second element, there's already a result and you don't go further, right? So that's the second case. Also, it could be used to compare these strings. And again, compare how you compare it. Basically, this one and this one, they are the same, right? So then you need to compare the second one. Second one, the first first character are the same, and the second one same, and the third one, this is L and this is M. If L is ahead of M in the alphabet, yes, true, right? So that's how it compares. So what if you change this Jones to Adams, right? And also, if this is greater than this, if we look at the first elements in this tuples and this one, basically J is ahead of A. Is it true? No. Basically, J is after A in the alpha beta. That means it's greater than A, and because here it is greater, so again it is true. If you change it to be a smaller, then it will be a false.
So the orientation of the sign doesn't actually matter, whether it's less than or greater than. It doesn't matter. It's just comparing it, or
of course it matters because you are actually looking at whether you compare it, how you compare it, because the sign, right? For example, if you switch this to be smaller, whether J is smaller than A.
Okay, so
it should be false, right? So basically, the only thing you need to pay attention to is if the two elements are the same, then you need to go further. So that's the only thing you need to compare, or you need to be aware.
For the Jones, Sally, Adams, Sam.
Yeah.
I guess the second one.
Yeah.
If you were to take Adams and Sam and put that and replace it with Jones and Sally, like actually invert them, the order of them, then it would come out as false also, right?
Can you say it again?
So Jones and Sally, and then you have the greater than symbol Adams and Sam. That comes out true, but if you were to invert them and put Adams and Sam where Jones and Sally are, and Jones and Sally where Adams and Sam are, would that come out false? I'm just not understanding why it's coming out true and why it's coming out false.
Oh, okay, sure. So you're talking about flip these two, right?
Yeah.
Okay. Oh, let's see.
Well, actually, like taking one tuple and replacing it with the other, like actually switching the order of them completely. Like you have Jones and Sally, you take them and you put that tuple on the other side of the sign.
Oh, you mean Adam Sam here?
Yes.
And John Sally here, but still to put this greater here, right?
Yeah, I'm just not understanding.
Yeah. Let's look at it.
Okay.
When we look at this kind of example, that will help us. So basically, you are saying, okay, if you have this kind of a statement, Adam, Sam, and Jones.
Right.
Okay, my drawing is bad, but I think you get it. All right, that if that's the case. So again, compare the two two words, right? According to the alpha beta. So first, Adam is different from Jones, so you can just look at this one. That means you don't need to go to Sam and Sally anymore because they are not the same. And if A is ahead of J, no, yes, that means A is smaller than J according to the alpha beta. So that means A is not greater than J, but you have greater sign here. So that means this statement is false. You got it?
I'm still confused, I think. Like what is it that makes it false?
Because let's define the rule for this kind of comparison of strings. So basically you are looking at alpha beta order, right? A, B, C, D, blah, blah, and Z, right? So
wait, so is it the first letter?
Yeah, first letter.
Oh, it's the first letter of the. Okay, that makes sense.
Yeah, exactly. Basically, it compares letter by letter. If if A, let's have some let's just make up some random case. Let's say this is not John, but also Adam, not S but E. Let's say you have some weird name like this, and you compare Adams together with this. So what you're gonna do is, okay, you compare the first letter, same. Okay, go further. Oh, again same, then go further, same, further.
Okay.
But this, they are different, and S is greater than E. I mean, in this order, if this is smaller and this is larger. I mean, if A is smallest, then Z is the greatest. It turns out, okay, S is greater than E, and it turns out this letter, is greater than this. So it's true if you put a name like this.
Right. Okay. I understand that now.
Yeah. I mean, it's a little weird because it's so ambiguous because there's no greater. Actually, there's no greater or smaller if you're looking at strings, but only the rules defined by someone, right? That's a made up rules. But for the numbers, it's more obvious. For this kind of words, it's trickier, but just give you some idea how it would work if you are comparing two tuples. Again, let's do some practice in the lab sessions, and then that will help you to understand.
Thank you.
Right? Yeah, good. So, sorry. So let's look at the sorting sorting functions for the tuples. As I mentioned, there's no sort functions or sort method associated with tuple directly, but we can take advantage of the ability to sort a list of tuples such that we will have a sort version of dictionary. As I mentioned previously, using the items function, you could generate a list. And in the list, each of the elements will be a tuple. And this tuple actually consists of the key and the value of the dictionary. So that's the logic. And then you could use the sort function to sort your these tuples according to the alpha beta by looking at their keys. So it sounds like a very complicated method, but if we take a specific example, you will find it's quite simple. So let's say you have this dictionary, and each dictionary and each element has a key and a value. In this case, A as the key and 10 as a value, B as a key, 1 as a value, C as a key, and 22 as a value. So what you could do is you use the items function, and turns out you will have a list. Basically, the list is something like this. And in the list, it has all 3 tuples. These tuples consist of the key and the value. So that will enable you to use this sorted function. There's a function called sorted, and you can directly apply it to the list of tuples. And turns out it will return a sorted a sorted list with consideration of the key in the alpha beta order. So as you can see here, A, B, C, they are in order because remember in dictionary there's no order, but sometimes you just want to have them ordered in many applications. For example, you are doing some statistic about what are the words appears in one article, and for the result you want to look at them in the alpha beta order of the words. So that kind of this kind of little method could help you to achieve it. So we can do this even more using some built-in functions, and of course the sorted function could return you a fully sorted result in different applications, different scenarios. All right. So as you can see, we have this dictionary again, and we can just have another list T, which will be assigned to the sorted result. And as you can see here, if we print out T, all the keys, all these items are sorted according to their keys in the alpha beta order. Also, if you want to use a for loop instead of this method, you can also do it. So basically, you have 2 variables, key and v, and then you use the sorted function applied to this list of tuples, and turns out again you have all these sorted result as well. For these examples, it doesn't make much sense, right? So what's this really used for? I will show you later on when we look at some examples for counting the words in an article. So that's a very similar applications with the one we have in the project, and also the previous practice. So another question has been raised, that is, what if instead of sorting according to the keys, how about we sort according to these values? And it could be the case. For example, you have a list of tuples. Their key are the words. For example, you have let me draw something. So you have you have a list, and this is the no. This is the tuples. Let's see, 100 times. All right, and is like 150 and can 200 and so on and so forth. Okay, I think this looks ridiculous. Let me erase. Okay, and let's say you have such a list. So as you can see here, the key are some words. Let's say you have scanned the whole article, and you have count how many times a word appears in this article. And the first, this key is the word, and the value is how many times it appears. So instead of printing them according to the alpha beta, which you can do using the sorted function, right? Another interesting question would be, can you print them from top to down according to how many times it appears? Meaning you want to print the most used ones as the first one, and then the second most used ones, and so on and so forth. So it actually requires a sorting not according to the key, but according to the values. You want to sort it according to how many times, according to how many times it appears, which is essential these values. So how can you do it? So basically, we just want to do some little trick by revert the key and the values like this. So you have a dictionary C, all right, and what you could do is define another list, which is an empty one, and use a for loop and the items function, right? Basically, this key variable and a v variable will be corresponded to the key and the values accordingly. And then you want to append each of the pairs by forming a tuple, and then append to this empty list. But the only thing different here is, instead of form this tuple from key to v, you are actually reverting them. So basically, v, the value, is the first one, and the key and the k is the second one. So it turns out what have been stored in the list will be something like this. So the value becomes a key, and the key becomes a value. I mean, in a simple way to describe it. So in that sense, if you still use the sort function, it will take this as a key and do the sort. And also, if you want to have a top-down order, meaning the greatest as the first one, you can put this variable reverse to be true, such that the sorted result will give you a top-down order. And it turns out you will have this kind of a result. So 22 is the greatest. So it has been put into the first one, and 10 is the second greatest, and it has been to the being put to be the second one, and so on and so forth. By doing so, what you could do is you will still remember this example. Basically, in this case, you will have what are the top, I would say, let's say 10, top 10 most used words in an article. So that's how we could have that using this simple trick. Basically reverse the key and the value in this dictionary using tuples and also the list. And probably we could do some example, like exercise, some challenge yourself to do some statistic in the lab session. And here show you a basically the code. Again, by reading a file, let's go through it. So you read this Romeo.txt and again, build up a dictionary. Why I know it's a dictionary? Why it is a dictionary? Any idea? Actually, by looking at this. So this is a curly braces that indicates this count is a dictionary. So again, through scan through each of the line in the file, basically it will split each of the line into a list of words and do this using the get method to have a dictionary with key as the words and the value as how many times it appears. And by going through this for loop, you have already got this dictionary field with the words as a key and the counts as the value. So the target is to find out the top 10 most common words, just to do what we have discussed in the previous slides. And that is go through this dictionary and define two variables, key and a var, and also an empty list. Again, swap the two. Make the value to be the key, make the key to be the value, and generate the tuples and append it to the list. Once you've done that, you are actually 90% done. The last thing is to sort it and make sure it's the reverse to be set to be true, such that you will have a top-down countdown, right? And also, you only want to have the top 10 most used words. Of course, you could set up to be 20 or 25. I don't know how many words there, but you could change this values. Turns out you will have the top 10 most commonly used words in this article to be printed. So that's how you would do using a Python programming and also different data structures and a little logic here. I would say it's much easier using Python to achieve this than many other languages. Actually, if you look at the C++ or even Java, it takes, even just for the file reading, it takes 5-6 times more codes to achieve same function. It's much easier using Python. And that's why people are looking at Python, because it's so easy to use it. And any questions regarding this countdown? I mean, this statistic. Okay, I think you might need a little practice by realizing such kind of function in your lab session. Then you will have more specific question. All right, and I will assure you we will have some similar practice in the lab sessions. So that could be some even a simpler way to achieve such a function by create a dynamic list. So let's look at it. Again, we have this dictionary created. We have A as the key, 10 as a value for the first element in the dictionary, and B1, C, 22, blah, blah. And then what you could do is, basically, you could just simply, let me see, you could simply use this one sentence of code by creating a dynamic list and sort it. So with this square braces, actually that represents a list. And in this list, you are going through all the elements in this dictionary by creating a tuple with the key and also the value in the dictionary. And again, you want to flip the two. Let the key to be value, let the value to be key, such that you could use the sort function directly to sort according to the value. And after you have execute all these code in one line, you will have the same result as we have for this, just using one line. But it looks more abstract compared to this. This is basically, it's a breakdown, right? You have each of the steps shown, and it's easier to understand. But this is also working in a more compact way. It does the same thing as what we have here. I would say each way is, I mean, either way works. Either would work for me, and I won't restrict you to only use this shorter version, more compact version, or this more breakdown version. But still, I mean, even for this longer version, it's very simple to use. So that's how we have this sort function, right? Of course, you could set up the reverse to be true, such that you will have a order in the top-down order. That means 22C will be the first, 10A will be the second, and 1B to be the last one, similarly. All right. So I think we have so far complete all the introduction about the data structures. We talk about the string as the first one, and then list, and then dictionary, and it turns out we have the tuples. I think together with all these data structure, you could really achieve very complex functions associated with Python, related to the file readings, some of the statistics when you have a series of data, and you could extract some strings, some values from a long string, long file, and do some counting according to your need. And you could sort those values again based on your need. So I would say that build a foundation for you to do some data analysis applications. So in the next, I mean, of course, we still have the object haven't been covered, but that will be covered in next lecture. And after that, I will introduce more mathematical libraries. Basically, that answers your question. That is, what if I have all my data extracted using all these data structure and file reading functions. What if we have these data already in hand? How are we going to process it? Is there any tools, any functions supported by Python? The answer is yes. We will learn how we're going to make use of this data by calling those mathematical functions in Python built-ins. But before that, let's have more practice in the lab sessions on Thursday about tuple and also the combination of all different data structures we have learned. As you can see, it's kind of more, you make use of the benefits from different data structures and combine them together to achieve a more complicated, more complex tasks. So that is what I want you to gain by going through these lectures. I think that's pretty much all for my lecturing, and I will stay here. And if you have any questions, you can ask. And yep, that's it. It is.